Dmitri Tymoczko. Okay, thank you very much. My talk today is going to have 3 parts. In the first part, I am going to explain what makes music sound good. And then in the second part, I am going to ask how the various properties that contribute to good sounding music can be combined. And we're going to explore the ways in which, what I'm essentially going to do is I'm going to how these properties can be combined. And the punchline is going to be that the properties constrain each other in non-trivial ways. So it's not like you can just willy-nilly mix and match them. If you want to have 2 of them at the same time, say, you really are quite limited in terms of what musical object you can use. And we're going to see that by representing music geometrically. Using an extremely simple geometrical representation, I'm just going to represent musical objects as collections of points on a circle. But this simple representation has the advantage of being very intuitive, and you can sort of you can see exactly how the various musical properties constrain each other when you realize how music can be represented circularly. The very natural musical concepts, the kind you explain to an 11-year-old beginning piano student, those musical concepts get translated into all sorts of exotic higher dimensional geometrical spaces. So you start to see things like Mobius strips or cones or various other interesting shapes naturally popping out the moment you try to represent simple objects geometrically. So part 1 of the talk is sort of pure music theory. Part 2 is a mixture of music theory and geometry. And then part 3 is where the more interesting geometry comes from.